The problem I've just wrote up asks us to find the particle's position at t equal to 8 minutes if we are given the velocity function y equals 2 plus 8 tons squared and that the particle's position is at 30 units to the right of the origin when time is equal to 0.
Teacher, isn't that integral problem on the board wrong?
Really, Jason? I don't understand why you can understand that problem.
Isn't it cough wrong?
Oh, really?
Yes, really. Should I tell you why?
All right. What did I do wrong?
Well, for starters we need to start with the velocity function y equals 2 plus 8 tons squared. Then, since we want to find the position of the particle we are graphing, at t equal to 8 minutes, then we need to take the integral of the velocity function on the interval t equal to 0 minutes to t equal to 8 minutes.
All right, I did that. Then what do I do?
Well, since we are doing this by hand, you need to take the antiderivative of the function. That would be 2 plus 16 tons plus c. However, since this is a defined integral, we don't need the c.
Right, then after you plug in a to the antiderivative and subtract it by the antiderivative with a 0 plugged into it, which is just 128 plus 2 plus 0, which I did.
Yes, you did, but you forgot to apply FTC2 to the problem and add 30, the initial position at time equal to 0. That would give you the particle's position, at 8 minutes, to be 160 units, not just 130.
So, since you showed me up on that last problem, how about explaining to me how to go about this derivative problem?
Sure. What's the problem?
Well, the problem is that we need to find the acceleration of this particle, moving along the x-axis, at t equal to 3 minutes, but we're only given the particle's position function. 2 tons plus 5 tons squared minus t to the 4th radical 4. So, how would we do it?
Well, to start we need to take the derivative of the position function so we can get the velocity function. Thus, we get 2 plus 10 tons minus 4 tons cubed radical 4 as the velocity function of the particle.
Alright, then what?
Well, now that we have the velocity function, we can take its derivative to find the particle's acceleration function. After everything's done, we get 10 minus 12 tons squared radical 4.